Hey everyone, Professor Bay here doing another video solution. This is on activity 8. One of the problems of this fish that's fishing, it's a fishing bird. It is diving and getting things. I'm still amazed. Like, how in the world did they do this? It's freaking amazing, people. But we're going to do some physics on this. This problem here, we've actually done this, right? We've essentially done part of this. We didn't solve for height before, but I think we solved for velocity in activity 8. And so we've seen something like this before. It starts up here, right? Here's your y1, your velocity is equal at rest. And later it's going to go straight down. It's at some velocity down here at y2, right? And when I do my coordinate axis like so, right? What do? Positive y upwards. I'm going to say this guy right here is at y equals 0 because that's like the seed, right? That's the fish. Poor fish. Sorry, fish. But, fish, birds got to eat. And we want to know, what's that displacement? What's your initial height? So it's looking for the magnitude, I think it's looking for. What height did it go for? So when we're talking about my displacement, right here, there's your displacement, delta y. We're going to solve for delta y. That h, that height, that's the magnitude, right? So height equals magnitude of my delta y, because y2 is equal to 0. All right, I have that. Have my picture. Now I'm going to be doing some graphs, because I love the graphs, right? In a Philios sort of way, in a lover of wisdom sort of way. Okay, here we go. Let's do this red. So my velocity in the y, in time, acceleration in the y at the time. Right, one of these is always the same, Acceleration in the y is gravity because it's free fall, right? So when this thing is going down in free fall. Now my velocity v1 looks like I start at 0. Right? This big one, it starts at 0, and I end at a velocity that is downwards in big, which is negative and away from the 0, connected by a straight line. That line better be a negative slope because my acceleration is negative, and it is. Great. I'm looking for delta y. So if I'm going to do delta y, which graph do I start on? Hopefully, you're answering that question with velocity, because the area of the velocity graph is displacement, delta y. Wonderful. All right, so I get my delta y is equal to 1/2 times time times delta v in the y, right? There's my base is time. There's my height, delta v in the y. Good deal. Okay, so which one of these am I looking for? Once again, it's looking for delta y. It means I have to know these values. I know the value of 1/2. Let's see, hits the water at 32, great, so I start at 0, I end at 32 meters per second, wonderful. It doesn't tell me anything about time, does it? So I don't know the time, which means I need to have another equation, right? There's one more graph to go, thank goodness, so we'll do that. I'm going to choose a color that's probably pretty awful. Yeah, not that orange is awful, but in terms of the contrast, delta Vy. I don't know delta Vy, I got to solve for it, and it's just G times T. There's my time. There's my G. All right. So make a substitution. Make it blue. I take that GT. And I plug it in where I see that. Oh, no. What am I doing? Getting ahead of myself, right? I don't know the time, so I have to solve for that time first. My kids would call me silly Dr. Ray. T equals delta V over G in the y. Now I can make a substitution because I needed to solve for that time. All right, so there we go. Make that, plug it in, make that substitution, and now we're rocking and rolling. So I get delta y is equal to 1/2 times delta Vy over G. That's why I substituted for time, times my delta Vy, which is 1/2 times delta Vy squared all over G. Start plugging in values. You're going to see these graphs probably again and again and again. But you see, we solve for something different every time. So the algebra and the substitutions are kind of different every time. But the physics is like the same all the time. Our pictures kind of always look something like this. Our graphs always kind of look something like this. So the graphs and the physics are kind of the same. The equations are essentially the same. But what you're trying to solve for is different. And again, that might be frustrating for you. Sorry about that. Or maybe you really like it. Yeah, I hope so, right? So let's run through this. 0.5 times delta V squared. So that's 32 times 32. take this divided by 9.81, and maybe hopefully I punched things into my calculator right. I did that a little fast, but I started 52 meters. Dang, that's like 150 feet. All right, 52.2 meters. Is that right? That's right. Wow, 150 feet. Well, because you don't want the fish to see you, right? All right, everybody, if this is helpful for you, maybe, consider. I'll ask, would you please consider, maybe liking the video on the Canvas. That way students know, hey, this one's really helpful.